Hello, friends, and welcome to episode 51 of the Our Weekly Highlights podcast. My name is Eric, and today we are covering the issue highlights for week 31, released on August 3rd, 2021. This week's issue was curated by Kelly Bodwin, with help from the Our Weekly team members and contributors. And as a quick heads up, as I'm recording this, my house is filled with a little gentle chaos, if you will, so if you hear some noise, I apologize in advance. At its core, a fundamental component of the R Markdown ecosystem is the ability to create a healthy mix of different output formats, which themselves are typically open standards. In fact, one can think of the various web formats, like HTML reports, as fundamentally open because they are just based on the HTML and CSS standards that are, of course, publicly available. Now, in my mind, the ideal situation is that communication of data analysis results would always be rooted in dynamic and interactive content with these open standards. Well, sometimes that's not quite the case, at least with the interactive part, as across many organizations within both industry and academia, documents and presentations are typically built with the Microsoft Office suite. Now, once Microsoft Office 2007 introduced support for the Microsoft Office Open XML standard, that's a mouthful, which actually itself has a somewhat peculiar history, the door opened for creating wrapper packages in various software languages to populate Word, Excel, and even PowerPoint documents dynamically with code. In fact, R Markdown itself has included support for creating Word documents as an output since nearly the beginning, and then later on gained the functionality for exporting to PowerPoint presentations, where this functionality is building off of the Pandoc utility. While these developments were happening, another branch of R packages in the R ecosystem targeted the Microsoft Office document format with their own functional paradigms. And the worlds of R Markdown and these more targeted packages have converged again recently with the advent of the Office Down package created by David Gohel. Allison Hill, product manager at our studio for data science communications, has authored her second friction log, serving as an experience journal on using Office Down to produce a PowerPoint slide deck in our first highlight for today. Now, one would realize pretty quickly that there is a bit of a difference in the community presence of users that are using the Office Down family of packages compared to general R Markdown. One of the first things that Allison found is that there seems to be very little traction in forums such as RStudio Community with this specific Office Down package. Now, I can shed a little light into this, as I was an early adopter of one of the key components of Office Down called the Officer package, which again has its own functional take on populating various Microsoft Office documents and PowerPoint presentations. This is typically something that somebody in a general data science role who does get more control into the type of outputs that they can generate probably will not be looking to as their first choice. But for those of us in the industry that live with the fact that our colleagues are, for better or worse, interpreting Microsoft documents in the Word document program or PowerPoints as their main way of consuming outputs, well, we still want to take advantage of R to at least populate these in a data-driven way. Allison continued her exploration of using the built-in R Markdown template file for Office Down, and that's where we see some of this more specific functionality that separates Office Down from general R Markdown. For instance, in the PowerPoint R Markdown template file, there is a special syntax for depicting which type of content is given on the slide. In general PowerPoint, you will often see layouts in, say, one column with a simple title, or you might see a slide that has two placeholders, if you will, side by side. Well, the Office Down package has different ways of treating those layouts depending on if you're putting only text or perhaps text mixed with a visualization. It does take some getting used to. It's not quite the same as organizing, say, a layout in a typical R Markdown document or even a Flex dashboard, but it certainly can be done. And one of the key advantages of the Office Down family of packages for creating PowerPoint slides, as opposed to the built-in R Markdown variation, is that all graphics produced are based in editable vector-based graphics, which means that somebody can go into the PowerPoint file and actually tweak a plot's appearance within the program itself should they choose to. There are a few steps involved for including plots via a few functions provided by the Officer and RVG packages, with again the goal of providing editable graphics in the slide. Allison did find that there is a bit of friction, you might say, with getting up to speed with these pretty quickly if you are just familiar with general R Markdown workflow. But perhaps with awareness of another R user trying this out, we'll get even more feedback to the maintainer of Office Down for future improvements and perhaps even user guides along the way. I even had a little fun with my early explorations of the previous Officer package when, ironically, I was a teaching assistant for Allison's Advanced R Markdown workshop back at RStudioConf a couple years ago. And I, of all people, had a short little presentation about leveraging Officer to create PowerPoint slide decks. And yes, I combined it with Shiny because why not? I'll have a link to that in the supplements section of this episode's show notes. But I commend Allison on providing her entire experience of adopting this framework, and it is an excellent way for somebody that may be curious about this framework to see what the experience is like firsthand and not just see the finished product of a code base. So I certainly hope to see more of these in the various realms of R Markdown from Allison soon. Back in episode 49 of this podcast, we touched on a great post by Mael Salmon on becoming a better code detective with awesome techniques that you as an R user can leverage to solve what could be some very complicated debugging issues. Well, here's a great illustration of many of the principles Mael mentioned with the recent blog post from Thomas Mock, which illustrates a very esoteric issue he encountered with producing a visualization of various sports statistics, the subject of our second highlight today. To get more specific, Thomas was preparing a visualization of quarterback ratings average over a time span, and he simply did a facet based on the ordering of greatest to least quarterback rating, or average quarterback rating. And when he produced the visualization, he noticed that the facets weren't quite going in the right order. In fact, they were almost a completely different order, quite random, compared to the obvious ordering that would occur by sorting the average quarterback ranking. Now, and this is a case where there is no obvious error warning, but that simply something is not right. So looking at the totality of the data importing, wrangling, and visualization, it can be hard to pick up just why the plot facets are not in the correct order. And why would the factor levels be wrong in the data going into the plot? So looking at being a little unclear on where a possible bug could it be in the ggplot package itself? Or could it be in 4cats? The next step for Thomas was to break down the problem into smaller components. The first step was to simulate a small data set that mimics the input data so that there wouldn't be a need to actually use the scraping packages to get the actual sports statistics data, and then to only derive the calculation that matters, in this case an average of groups. Through that first step of this reprex, Thomas showed that the order based on descending average did not match the factor levels, and that the same thing actually happened with visualizations. Now, of course, he did show what we call a Band-Aid type solution of reordering the levels inside the facet step with the 4cats package, and that did fix the issue. But interestingly enough, that Band-Aid revealed the logic gap in the earlier data analysis pipeline. What happened is that Thomas was producing the factor transformation inside the group by operation in the dplyr pipeline. In essence, that was creating level 1 type factors that were again stitched together at the end of the aggregation. Now, by moving that piece of code to before the grouping operation, everything resolved as it should be. That goes to show you that even just the act of creating a reprex, more often than not, will be able to solve your issue once you're able to compartmentalize the key components and then be able to transparently discover where the issue is actually occurring. Again, it's a great illustration of a great principle in action of making your problem smaller, and as Jenny Bryan referred to, talking to what may be amounting to a rubber duck to explain your problem in great detail. I commend Thomas of another excellent post, and I look forward to his actual larger post on the quarterback rankings and other statistics, as he's a pretty big sports fan as well. We have seen some great advancements in how the tidyverse philosophy of data processing with the tidy framework has supercharged many workflows, certainly in data processing itself, which is most well known, but also recently with the modeling piece as spearheaded by Max Kuhn and his team at RStudio for the tidy models framework. Well, what's interesting is that those same principles can be applied to other pieces of a statistical analysis pipeline, such as basic inference tests that you might see in a general statistics course, such as two-sample t-tests or analysis of variance modeling. And that's where Indijit Patel, postdoctoral fellow at Max Planck Institute of Human Development, has developed a very promising R package that fits right in with this tidy philosophy called stats expressions. And we'll dive into that a little bit in this last highlight for today. Much like what the modeling framework of packages has encountered in development of tidy models, there can be quite variation in the types of inputs necessary for a lot of the inference functions in R. Sometimes you just need a vector. Sometimes you need very wide data sets or perhaps even a matrix, which of course leads to a bit of variation when you want to have a unified philosophy of perhaps comparing multiple inference or modeling techniques. What stats expression does is that it simply gives you a tidy input framework and with simple functions that expect a tidy data frame as input to produce statistical output from conducting hypothesis testing and perhaps even some basic modeling along with that. And along the way of getting the model output or inference output as tidy data, this package also returns what's called an expression object, which is a great way to put in the more statistical notation version of your estimates and inferences inside, say, ggplots. The README of stats expressions serves as a great tutorial for getting you up to speed quickly, with concrete examples for all the different inference methods that are included into the package, and being able to see how those stats expression objects can be superimposed on different parts of a ggplot, whether it's in the title of the plot or even to annotate various points on a simple plot. For those that wish to customize those type of expressions outputted, Indijit also shares example code for how you can take components of that and put it into wherever you like in a ggplot call. Like many packages in the R community, Indijit has also put this package on GitHub, and he is always welcoming bug reports, feature requests, and general feedback as he continues developing the package. I'll certainly keep an eye on this if I need to leverage multiple inference or basic modeling methods in my data analysis pipelines in the future. And those are your R Weekly highlights for today. Kelly's done an excellent job with this release, and there are many other great resources for you to dive into, such as a great tutorial on visualizing data with rain cloud plots and a mid-season review of the 2021 Japan Football League by our own curator, Ryo Nakagawara, and much more. As always, Head to rweekly.org to find all the links from this issue and, of course, all of our previous issues as well. And you can find all the episode show notes for this and previous episodes at the podcast link directly at the top of the page. We always welcome your feedback for suggestions and improvements. You can provide your feedback directly at the rweekly.org site. And of course, if you have feedback on this specific podcast, feel free to drop me a line. You can shout me on Twitter with @thercast, or you can definitely fill out the contact page directly on the podcast page itself. Have a fantastic week, and we'll be back with another batch of our weekly highlights next week.